Right. So let's see how to find stationary point. So what is meant by a stationary point? So we learned in the previous video what happens to the derivative. So what is the sign of the derivative when the function is increasing, or what happens to the sign of the derivative when the function is decreasing. So these things will be were studied, right? So I have sketched a general curve here. You can see. So we have a minimum point, two minimum points, and one maximum point, and we have another point here. Right. So how do you figure out, how do you determine these points using the derivative? So this is the idea behind this this unit, because this is under applications of derivatives, right? Applications of derivatives. So we need to know how to use the derivative to find these special points. So what happens if the function is decreasing? You can see our derivative, this tangent line. Imagine this is our tangent line. Tangent line is negative. Then what happens at this point? At this point, our tangent line is horizontal. Then if you increase in again, then what happens here? The tangent line is horizontal. Then decreasing again, here horizontal, increasing. At this point horizontal, then again increasing. So what happens at these four special points? We saw that our directed line segment over the tangent line is horizontal. These are horizontal, right? The horizontal. Now, to find these, so what happens to the derivative? So derivative of the function, if the tangent line is horizontal, what is the gradient? Gradient must be 0. Again, f dash of x here is 0. So let's take these points. This is A, this is B, this is C, this is D, right? So I didn't come to this just yet. And at all these points, so this is at B, and f dash of A again 0, f dash of C 0, f dash of D again 0. So you can see the derivative at these points is 0. It doesn't say anything about whether it's a maxima or minima, or we call them inflections. It doesn't say anything about them. It doesn't distinguish between them, but it says that it must be a stationary point. So we'll see how to distinguish between these next, but you should know that to find turning points in general, or stationary points in general, we have to make our derivative equal to 0. Or in other words, the x values for which our derivative is 0 will give us the x coordinate at these points. It will only give us the x coordinate. So I can generalize it. Given a function, if for any x equal a, any x value, it implies f dash. So you can see f dash is here, f prime or f dash, whatever you call it, f prime of a. F prime means the derivative at that given point is equal to 0. If this is the case, then this point, so what is this point? Here this is the x value, x coordinate, this is x coordinate, and this would be the y coordinate. How do you determine the y coordinate? Just put a there. So this is f of a. This is how you figure out these coordinates. So we'll get to that. Is called a stationary point or a turning point. Okay. So this is in general, this is called, these two are called minimums, and this is a maximum point, and this is called a point of inflection. Inflection, point of inflection, right? So we can have it the other way, like this. Inflection. Okay. Right. So notice here, so this is what we are going to do to figure out, to distinguish between them. Just before x equal a, our directed line segments looks like this. After a, line segments looks like this. So you can see these directed line segments tells us the shape of the curve at this point. So this curves like this. So what about here? Our line segments are like this, increasing, decreasing. So curves like this. Again, same way. Right? But here, what happens? Directed line segment, the sign do not change. It does not change at a point of inflection. So that's how we distinguish. Right. So we'll talk about this in detail soon. Right. So these are the shapes. A minima would look like this. So if you figure out that the given point or a point is a minima, then when you sketch the curve, you should sketch it like this. If it is a maxima, should be sketched like this. If it is an inflection, decreasing, that means the function will always be decreasing on that interval, the containing the stationary point. So you can see decreasing and increasing. So let's look at the directed line segments. So at this point, obviously horizontal, 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 again horizontal. Then what happens in the neighborhood? On this side, onto the left, you have directed line segment like this, which implies is negative, and this implies positive. Here, positive, negative, 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 then positive, positive. Directed line segments are positive. So at this point, directed line segment is positive, meaning what does that imply? It implies f dash of x at this point is 0. F dash is 0. So on this side, f dash of x is negative. On this side, f dash of x is positive. So here, f dash of x is 0. F dash of x is positive, f dash of x is negative. Here f dash of x is negative, and the sign does not change, same value, but at the point the value is 0. F dash of x is 0, f dash, the derivative is positive on this region, and also it is positive in this region. They are all positive. Positive, 0, positive. Negative, 0, negative. Negative, 0, positive. Positive, 0, negative. Right. So this is what we have to sketch, but you're not going to sketch it directly. Before that, you need to figure out the shape. To figure out shape, we need the directed line segments. So this is what we are going to do. We're going to figure out these line segments. So as I mentioned earlier, the visual representation, if it is negative, it represents like this. 0, a horizontal line, positive, a line like this. So you can see this actually implies our curve goes like this, right? This is a sort of an implication to that. Here, horizontal line, this is negative, so this is then, so this is positive, this is negative. Negative lines are like this. You can see this sort of looks like the function is doing this. Next here what happens? Horizontal, then like this, and finally like this. You can see the shape here, right? Again here, horizontal, there you are, all the shapes too. So keep this in mind, keep these shapes in mind, and let's do some examples on this, and now we can incorporate increasing and decreasing functions into this as well, because we need to know the sign of the function besides these 2 points. Okay, wait for that. Right. So determine the stationary points and intervals in which the function increases or decreases. Right. So to find the increasing and decreasing regions of the functions, we have to take the derivative, and also to find the stationary points, we have to take the derivative. So let's take the derivative first. Dy by dx, this would be 4x cube minus 4x. This would be 0. So you can see 4x is common. Let's factor it out, and we are left with x squared minus 1. So we can keep on simplifying this one. So this is 4x, x minus 1, x minus x plus 1. Right. So how do you find the stationary points? To find the x values of the stationary points, so we just equate this to 0. Right? Equate this to 0. For stationary points, set dy by dx, equal to 0. So this implies 4x, x minus 1, x plus 1 equal to 0. So what does that imply? Now 4 is a constant, you can just get rid of this constant, it doesn't matter. So we have a product of 3 factors equal to 0. It could only mean x equals 0 or x equal 1, x equal minus 1. So this is the for x values of the stationary points. Let's say for x values of stationary points. For x values of stationary points. Okay. So we have figured out all the x values. So when x equals 0, x equal 1, x equal minus 1, the derivative of the function is equal to 0. So which means we have turning points at these 3 points. So we have to figure out the turning points. These are just x values. So how do you get turning points from this? To get turn points, you have to apply these set of values to this function and figure out the corresponding y. So the corresponding y in this case would be x equals 0, y would be 1. Then at x equal 1, y would be, this is 1 minus 1, this is 0. At x equal minus 1, this would be again, I think, 0. Yes. So the stationary points being 0, 1, 1, 0, minus 1, 0. So stationary points would be 0, 1, 1, 0, and minus 1, 0. These are our stationary points. So we figure out the stationary points, but we don't know what they are. They could be maximas or minimums or point of inflections. Now you can go about this like this, or you can just refer to the number line directly and gather data from that. So let's look at the number lines, right? So we don't really have to do it like this. We can just do it right below the number line. Let's see how to do that. Now we have to use our brain for this one. The number line, draw the number line. So what are the x values? X equals 0, x equal 1, x equal minus 1. So 0 is in the middle, then minus 1, then plus 1. So how many regions, intervals are there? So we have interval 1, interval 2, interval 3, interval 4. In general, if we have 3 critical values, then we have 4 intervals. Then here sign of f dash of x. Okay. Now how many factors are there? So 4 is positive, so we don't really have to consider this. These are the 3 factors. So I'm going to put 3 brackets like this. Then see what happens. So at this point, at these points, it is 0. So you don't really have to mention it here for the moment. Now, if when x is less than minus 1, this would be negative, this would be negative, and this would be also negative. So the product would be negative, the product would be negative. Minus 1 and 0, this would still be negative, this would be negative, but this would be positive. So here this would be positive, positive into positive, that is positive. Between 0 and 1, this is obviously positive, this would still be negative, this is positive, so this would be negative, and finally greater than 1, all 3 positive. Right, so you can see the sign changes. Next, based on this, we have to find, now based on this we can find the regions in which the function increases or decreases, but we also need to find the nature of the points, right? Earlier we figured out the points, but we don't know what they are, so we have to use this to figure it out. So you can use directed line segments. Now here's what I'm going to do. I'm going to draw discontinuous line like this, and I'm going to draw the shape of f dash of x. So what is the shape? At these points, they are all horizontal. Here it is negative, it means a line segment like this, positive, a line segment like this. Then here you can see we are still in this region, so it is positive, but you draw it here. Then this is negative, draw it like this. In this, we are still in this region, it is negative, so draw it like this, 0, then positive. So based on these directed line segments, you know what the shape of this the function looks like. So next we write the shape of the function f of x. The shape of this function, the shape must be like this, right? And here the shape should be like this, and here the shape should be like this. So what are these? These two are minimums and this would be a maximum. So what are the points? We figure it out first. So this point is minus 1, x equal minus 1. You put minus 1, you get 0 to be y. This is a minimum. You have to mention this minimum. Then here we have maximum. At x equals 0, at x equals 0, y is 1. This is our maximum point. Then here we have the x value is plus 1. Again, if you put plus 1, we get 0. This would be a minimum. So we are still not sketching any curves, we are just simply building up to it. And if these are the basic skills that you need, if you have a strong foundation on these parts, then sketching a curve it's not that difficult, it's very simple. Right. So we'll do more questions on these, especially with the rational functions. So when it comes to rational functions, we get asymptotes as well. So let's do such questions in the class. Okay, so thank you for watching.